In 1.7, and we're talking about midpoint and distance. So mostly so far we've used the things we've done with geometry. We just had our figures drawn on a sheet of paper and we're figuring some things out about them. But sometimes we need to work with our points in on a coordinate system, on a graph, and we want to know how we deal with points when they're on a graph. They're not just nicely laid out on a number line for us. So let's remember, or let's kind of think about what we're talking about when we're talking about a midpoint. What do we mean by midpoint? The point in the middle. How is the midpoint? If we had 2 points, how can we think of the midpoint? How would we find the midpoint if we have a number line? Halfway. So that's really what we're talking about, is halfway. Halfway between points. So if we have some points on a number line, we have them laid out nicely like this. So we had a couple of questions laid out on a number line on the quiz. And we knew that this is at -3, and this is at 7. So 0 is going to be somewhere over here. How could we figure out what is halfway between those two? We could construct a bisector, but if we have coordinates, can't we figure out exactly what the middle is? So how would we go about it? Anybody have an idea? So what if, instead of -3, what if our point was here at what if we were here at +3? Could we figure out what's in the middle of those two? Subtract the two numbers, and what would that tell us? And divide by 2. So that would tell us if we subtracted these two, 7 minus 3 is 4, divided by 2 is 2. So what does that tell us? That our midpoint is, what is it? So I hold on to that idea. So if we subtract them and divide by 2, that tells us that the midpoint is 2 units away from each of these. So what point would be 2 units away from 3 and 2 units away from 7? 5. Okay? Now Mitchell says an easier way to do it is add them together and divide by 2. When we add them together and divide by 2, we're finding the average of those two. And that will give us our point. So halfway between 3 and 7, we're going to do 3 plus 7 divided by 2. 3 plus 7 is 10. Divided by 2, I get the point 5. So I know my number line isn't to scale, but we would get 5. So halfway between those two is the point 5. We add them together and divide by 2. We're finding the average. So let's do that with 7 and -3. I'm going to do -3 plus 7 divided by 2. -3 plus 7 is 4, divided by 2 is 2. So halfway between -3 and 7 would be 2. So I add the two together and divide by 2. And we want to, it's a little harder. We could count spaces maybe and find our midpoint that way, But if we have really big numbers or decimals or fractions, we want to use this process. And I'm just going to circle this so we know which number went where in my different colors. So on the number line, so our rule so our midpoint between 2 points our points are A and B is A plus B divided by 2. And if I draw a picture here, here's my number line, here's A, here's B, and we say that our formula, if we think of it as a formula, M for midpoint is A plus B divided by 2. And our midpoint would be that point there. So we find the average of those 2 points. Now it gets more complicated if our numbers aren't on a number line, if they're just somewhere on the plane, so somewhere on a graph. But we can do something that's kind of like this for a midpoint of points on a graph. So let's say we have points, and I'm just going to draw an x and a y axis here. So we have this graph here. And we have 2 points on my graph. So it's not right along the x-axis. So it's not on a number line. And this is point A, and this is point B. I'm going to join them by a segment. And we want to find the midpoint of that segment. It's just a little, there's just one extra step that we have here. So I'm going to call this one, we're going to name this point, we're going to find the coordinates of this point. I'm going to call the coordinates x1 and y1. So those are just the x and the y coordinates for that point. I'm going to call the coordinates of this one x2 and y2. Doesn't matter which one I call 1 and which one I call 2. I just have to keep the 1's together and the 2's together. So our midpoint, we need 2 numbers, because we're going to have an x, a number for the x, and a number for the y. So our midpoint is right there in the middle. We need 2 numbers, one for the x and one for the y. All we're going to do is do what we just did on the number line, but we're going to do it once for the x part of it and once for the y part of it. So we're going to average each coordinate. So our midpoint between these segments, or between the points, x1, y1, and x2, y2, we just do what we did for one midpoint for the x and for the y. I'm going to say m equals, and we have a point here, so we need 2 numbers, x1 plus x2 divided by 2. There's my x part. I'm going to call that x. And y1 plus y2 divided by 2. And that's the y part of my midpoint. So the coordinates of my midpoint are going to be x and y. So we just need 2 numbers. We average the x's and we average the y's. So my midpoint, I get a point, an x and a y. So it's just like we did on the number line, but we do it once for the x and once for the y. So let's look at a couple of examples of finding the midpoint of a segment. So we want to find the midpoint between negative 3, 5, and to, I'm going to do 3, 7. So what I recommend when we're doing these kinds of problems with coordinates is let's label our points. So I'm going to label this one x1 and y1 and x2 and y2. Doesn't matter which one we call x1, y1, x2, y2. We just have to keep the x's, or the ones with the same points and the twos with the same point. So the ones stay together, the twos stay together. And then I'm going to plug them into my formula. My midpoint, x1 plus x2, negative 3 plus 3, divided by 2, is my x, and y1 plus y2, divided by 2, is my y. So now I'm going to work with these. Negative 3 plus 3 is 0, divided by 2 is still 0. 5 plus 7 is 12, divided by 2 is 6. So the midpoint between negative 3, 5 and 3, 7 would be the point 0, 6. We could go to my graph and plot that point 0, 6. So we're doing just like we did on the number line. We're averaging the x's, averaging the y's. So let's look at one more. Between negative 5, negative 3, and negative 3, 9. So we're finding the midpoint between these 2 points. So let's label these x1, y1, x2, y2. Keep track of what's going on here. And plug into my midpoint formula. Midpoint is x1 plus x2, negative 5 plus negative 3, divided by 2. That's my x. And y1 plus y2, negative 3 plus 9, divided by 2. That's my y. So I'm going to simplify this. My midpoint, negative 5 plus negative 3 is negative 8. Divided by 2 is negative 4. Negative 3 plus 9 is 6. Divided by 2 is 3. So there's my midpoint. So for midpoint, I need 2 points, an x and a y. Let's put the electronics away, please. So there's my midpoint. I'm averaging the x's and the y's. Now what happens if we have a slightly different kind of problem? What happens if we have the midpoint and one endpoint, and we want to find the other endpoint? So we end up, we have a different set of information, but it's still information about the endpoint, or the midpoint. So I want to do an example like that. So let's say we have the midpoint of some segment LM is 2, negative 1. One endpoint L, so the point L at this one end of the segment, is negative 3, negative 5. We want the other endpoint. we want to find out the other endpoint. So we have one endpoint of this segment, and we know the midpoint. Well, we know that what we've done so far is I said, let's label our points. So our points are, or I'm going to say endpoints. Endpoints are -3, -5, and we don't know the other one. So let's call this one x1, y1. So we don't know the other one, so we're just going to call it x2, y2. We don't know what it is. And we're just going to call the point x2, y2. We're doing just like we did before. We're labeling our points. We don't know what this one is. And we're going to plug this into our midpoint formula. Well, the midpoint, so we're going to plug these into the midpoint formula. Plug in what we have and solve for what we don't have. So we're going to plug in what we have and solve for what we need. Well, the midpoint is 2, -1. That equals, that's our midpoint, that equals x1 plus x2, -3 plus x2 divided by 2. And the y-coordinate is y1 plus y2 divided by 2. Well, this is my x and my y of my midpoint. This is the x and the y of my midpoint also. This is the x and the y from my formula. The x's are the same and the y's are the same. So 2 equals -3 plus x2 divided by 2. So how are we going to find x2 from here? What do we want to do? How do we get x2 by itself? Can we add 3? This 2 is dividing the whole thing. Multiply by 2. Multiply everything by 2. So I'm going to multiply by 2. And I get 4 equals, and these cancel out, -3 plus x2. Now what can I do? Leif? What did you say before?
Oh yeah, add 3.
Add 3. Now we can add 3. Because I don't have that in the fraction. Now I'm going to turn this around and say x2 equals 7. So there's the x coordinate of the other endpoint. And I'm going to do the same thing for the y coordinate. So I'm going to say and -1, the y part, equals -5 plus y2 divided by 2. And I solved this problem the same way. So what's my first step here? What do I want to do? I want to get rid of this 2 in the bottom here. So what do I do to get rid of that 2? Multiply by 2. -1 times 2 is -2. So let me change the color there. Those cancel and I get -5 plus y2. Add 5 to both sides. Turn it around, I get y2. 5 plus -2 is 3. So the other endpoint M is the point 7, 3. So I just plugged in what I had into my midpoint formula and solved for the part that we didn't have. I called the second endpoint x2, y2, just like we've been doing in the other examples. We just didn't have a number for it yet. We had to find the numbers. So now we know how to find the midpoint, and if we have a midpoint in one end, we can find the other end. All right, any questions before we go on? All right, let's talk about distance. We can find the midpoint between 2 points in the plane. We can also find the distance. So when we were talking about a number line, if we had numbers on a number line, I'm going to just write up here. We had an easy way to find the distance between our points, didn't we? So if we have a number line, and we have 2 points on our number line, how do we find the distance between those 2 points? If we had, let's say this is -3 and this is 7 again. So how can we find the distance between those 2 points? What's the easiest way to find the distance? But just looking at the number line, what did we do the very first time we learned to do this? Just count spaces. We could just count spaces and find the distance between them, right? And then when we learn more, we could say, oh, we can just we're going to do we want to add these to find the distance? No, what do we want to do? Subtract. So the distance between 7 and -3 would be 7 minus -3, and we'd get 10. So I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We want to subtract. So that's how we did distance before. Counting spaces, subtracting. Pretty easy. But if we have 2 points on the plane, so like we did with our midpoint, here are our axes, our x and y axis. And I'm going to call this one, the coordinates of this one x1, y1, and the coordinates of this one x2, y2, like we did before. We need to find the distance between these two. Well, we can't just count spaces now because it goes on this, sort of on this diagonal. We have a nice formula that works for distance. Our distance between x1, y1 and x2, y2 is the square root of x2 minus x1 squared plus y2 minus y1 squared. And for distance, we get one number. For midpoint, we get 2, one for the x, one for the y. For the distance, we just get the distance. And what we're looking for here, this is the distance, the length of that segment. The distance is the length of that segment. And what we're really doing here is turning this into a right triangle. And we're using the Pythagorean theorem. The distance formula comes from the Pythagorean theorem. And we'll talk more about that later in the year. So this formula lets us find the distance between 2 points. And we could get the points, the problem might give us the points. It might say the points are such and such and such and such. Or they might be plotted on a graph. If they're plotted on a graph, we can find the x's and the y's just by looking at the graphs. So let's do a couple of examples of calculating distance, and I want to show you a few things to be careful of. Distance between -3, 5 and 2, -3. So we're going to do the same thing we did with our midpoint. I'm going to label this x1, y1, x2, y2. Doesn't matter which ones are ones and twos, just the ones and the twos have to stay together. You don't want to mix ones and twos inside a parenthesis. And then I'm just going to plug this into my formula. So my distance equals the square root of x2 minus x1. 2 minus negative 3 squared. Plus y2 minus y1. Negative 3 minus 5 squared. And let's simplify this first. Remember our order of operations, we have to do parentheses first. So negative 2 minus 3 is minus negative, or 2 minus negative 3 is negative, and a negative makes a positive. So this is 5 squared. I'm going to leave it written that way. Plus negative 3 minus 5 is negative 8. Negative 3 minus 5 is negative 8 squared. When I do this next step, 5 squared is 25 plus negative 8 squared. Negative 8 times negative 8 is 64. I should never, after I square things, I should never have a negative underneath the square root. So once I get to this step where I've squared everything, everything should be positive. So this, you don't want to bring this negative sign outside here. Should always get positives after I square everything. The square root, so 25 plus 64 is 89, square root of 89, and then I would plug that in my calculator and calculate. So let me grab a calculator. We'll calculate the square root of 89. About 9.4. So I'm going to say approximately 9.4. And our length, depending on what the problem is, our length is always going to be in units. So inches, meters, miles, centimeters. So I'm going to say 9.5 units. And this will be important because next time we're going to talk about area, and we'll talk about square units, square feet, square inches, square yards. All right, so let's look at one more example using the distance formula. So let me go back really quick. Any questions before we go on? We're just plugging into our formula and calculating. Okay. We want to find the length of the segment between 9, negative 2, and negative 3, 6. So we're asking this question in a slightly different way. It says the length of this segment, and it gives us the endpoints of the segment. We have these 2 points. The length is asking us about the distance. We want the distance between them. The length of the segment is the distance between them. So we're asking, this question is asking us about distance. So we'll plug into our distance formula. Let's label our points. x1, y1, x2, y2. Keep the 1s and the 2s together. Square root of x1 minus x2, 9 minus negative 3 squared, plus y1 minus y2, negative 2 minus 6 squared. You can do it. You can do it either way. You can do it either way. I did it backwards there. I could. So I could call this one x2 and y2, and this one x1 and y1. So the order doesn't matter. Thank you. So let's keep going. 9 minus negative 3, 12. So I get 12 squared plus negative 2 minus 6, negative 8 squared. 12 squared is 144. Negative 8 squared, we just had that one, 64. So we get the square root of 208. And we plug that into our calculator, and we get 14, about 14.4. So it's about 14.4 units between these two segments, or between these 2 points. The length of that segment would be 14.4 units. If our grid were laid out in inches, it would be about 14.4 inches. If we were laid out in miles, it'd be about 14.4 miles. Questions on midpoint or distance?